This is an edge finder, and all it is just a cylindrical shaft. This one here, I believe, is 3/8 of an inch in diameter, and the end of it's actually smaller. In this case, it's 200,000ths of an inch in diameter. The end is actually spring-loaded, so it can be pushed off of center, which you'll see in the video to follow. The idea is it's to be put in the spindle, and the center of the shaft, or the middle of this small diameter, is meant to represent the center of the spindle. Okay, so we have this piece in the vise on the milling machine, and we're going to bring the edge finder, which is in a collet chuck, up to the side of it. Please notice that the bottom of the edge finder is wobbling off center. So now we're going to move the table longitudinally in the x-axis till the bottom just touches the edge of the part, and you will notice this edge finder will start to turn true, and we want to keep slowly moving it until it just kicks out again. So it's starting to turn true. So it's turning fairly true, and we want to keep going until, there it is. So it's just kicked out. Now what we're going to do is we're going to set the digital readout to 0 on the x-axis. Back to the part. Now what we want to do is we want to drop the knee or the Z until this clears the top of the part. So now this edge finder is 200,000ths of an inch thick on the end of it. Don't let it fool you that it's running out. It is still half of the diameter of the end of it away from the edge of the part. So now we're going to move the table until the digital readout is 100 thou. And the table is moving. Hopefully you can see the center of this edge finder coming into the center of the part. And if we look at the digital readout, you can see it now is at 100 thou. So we're going to zero it one last time. And now we're going to move the distance in the x-axis on the part. In this case, we've scribed a line at 1 inch in from the edge. So now we'll move the table in the x-axis 1 inch. And you can see the edge finder moving towards that first line. And the digital readout now is at 1 inch in the x-axis. And what we'll do is we'll hit that X one last time. So what we're saying is from the edge of that part, we're 1 inch in from the edge. Now we need to set it in the second position, or the Y position. And this is a traverse movement on the table of the milling machine. So what we're going to do is we're going to move it so we clear the edge of the part. And we'll end up bringing that knee up again so the edge finder can touch the edge of the part. Okay, and we'll bring that knee towards it. Again, we want to watch it so this edge finder just starts to turn true and kicks out again. And this is the traverse movement, or the Y. And there it is. It's just kicked out. So we'll go back to the digital readout again. And this time we will zero the Y. We'll drop the knee. And we'll move it 100 thou, or half of the diameter of the end of this edge finder. Again, back to the digital readout. And this can be done on the graduated collars on the dial. It doesn't need a digital readout. And we'll hit the Y. And now we'll move it to the position we want. In this case, we're going to have 1 inch in from the Y also. One last time, back to the digital readout. We'll zero it. Now you can see the X and the Y are both at 0. So what we're saying is the center of the spindle is now 1 inch off the edge of the part in 2 directions. In the X position and also in the Y position. Now we can put our cutting tool in and we can do whatever we need to do. Center drill, drill, and the center of this hole will be 1 inch off of those 2 axes. Okay, so we now have the cutting tool in the spindle. In this case, it's a center drill, and it should be located over the hole that we want to drill. So now we can just start peck drilling. And if we relieve the center drill, you can see it's right in the position we want. And we can do whatever we need to do. Drill, tap, bore, so on and so forth. So that is located exactly 1 inch off of the X and off of the Y axis on this part.